To conclude our unit on functions, we're going to talk today about inverse functions. So to start, you have a lot of definitions in your notes packet, and we're going to be going through some of those. You don't have a lot of notes to actually write down today. Unfortunately, you just get to listen to me explain all of those definitions that you have. So a function g of x is said to be the inverse of f of x if and only if this relationship is true. We have studied composition of functions, so if you take g of x and you put it into f of x, it should get you the exact same answer as if you take f of x and put it into g of x. And both of those answers should simplify down to just result in an answer of x. So both of these things have to be true. They have to result in an answer of x. If that's true, then we say g of x is equal to the inverse of f of x. So this f to the negative 1 does not mean a reciprocal, it just means it's the inverse function. That's how we'll notate that. You might also see h inverse or k inverse, etc. It just means it's the inverse function. In order for a function to have an inverse, it has to be what we call one-to-one. So we know our basic definition of a function is one in, one out, okay? But specifically to be one-to-one, you have to have one input creating an output, that's the function part, and one output has only one input, okay? So it's one in, one out in both directions, essentially. So thinking about this graph of a parabola, if I put in, we'll say this value a, I get back this output, we'll call it b. But if I put in c, I also get back b. That can't happen because one output only had one input. If I look at this output of b, I could have said the input was a, or I could have said the input was c. That's a problem. This is not one-to-one. Looking at this square root graph over here that's been shifted somehow, if I take, let's say, this a value and I plug it in, I get some y value of b. Is there any other b value that has an input? No. So this is one-to-one. So how do we test for one-to-one without actually having to plot points and think about the whole thing? Well, just like a vertical line test helped you to create, or helped you to know if you had a function, this time to create a one-to-one and know if that's going to work, you can use the horizontal line test. So if I give myself a horizontal line, there we go. If I were to take that horizontal line and drag it across my graph, at any point are blue and orange touching twice? Yes. That's going to be a problem. That one's not one-to-one. But if I take that orange line and I drag it along this graph, is there any point where orange and blue intersect more than once? No, there's not, which is why this one is one-to-one. Alright, some important features to keep in mind when talking about f and its inverse. First thing is the graph of f is reflecting over the line y equals x, and that creates the new picture. So if you think about a coordinate grid, and I've got the line y equals x, okay? Whatever function I had up here, okay, that's a point on a function, is now going to reflect over the line y equals x. It's going to be mirrored on the other side. So we've done reflections over the x-axis, we've done reflections over the y-axis, now we're talking about a reflection over a line. If the point AB is on f of x, then the point BA is on f inverse. Well, same thing. If I go over and then up to get to this point, I'm now going to go over this amount and up this amount to get my reflected point. You're reflecting over the line y equals x, which means that your y value now becomes your x value, and your x value now becomes your y value. Keeping in mind switching x's and y's, it would make sense then that your domain of f of x, stop would be your inputs, now becomes the range of f inverse. Make a prediction. The range of f of x, which is all of those b points, is now becoming the domain, the inputs for your inverse. So we've looked at these circles before. If I have x and it's turning into f of x, that means I applied the function f. Well, then to undo f of x and turn it back into x, I want to apply the inverse. I want to undo what I did to get back to my x value. That's where the composition comes in. If you have an input of x and you apply f of x and then take f inverse of f, you get right back to the x value where you started. Alright, this one you do have notes on. Given the graph of f of x, sketch a graph of f inverse. So to help us out, I'm going to apply some points. I'm going to say this is the point 1, 0. I'll say this is the point 2, 1. And this is the point 5, 2, which means this is a square root graph that's been shifted over 1, if you're keeping up with last lessons. So the easiest way to sketch the graph is you can picture in your head that line y equals x, but you can also apply what we know about the points. Well, on our purple graph we had the point 1, 0, which means on our inverse graph we need the point 0, 1. If we had the point 2, 1, now we're going to have the point 1, 2, and we had the point 5, 2, so now we have the point 2, 5. So let's go ahead and plot those points that are in green. I'm going to go 0, 1, just approximating. I'm going to go over 1 up 2. I'm going to go over 2 up 5. Now the shape of my graph has not changed at all, so I want to connect those dots just as they were. And if you notice, there's a mirror going on across that line y equals x. That's your introduction to inverses.